conic section, it's got that general form ax squared plus cy squared plus dx plus ey plus f, right? It's written somewhere on your conics reference sheet. At the very bottom, that's the general form. And you can classify it by looking at a and c, right? So the coefficient on x squared and the coefficient on y squared, in this case, are both 1, right? So a is 1 in this case, c is 1, a equals c, right? Which tells you that this is a circle. Right? So if a equals c, it's a circle. If a times c is 0, it's a parabola. If a times c is positive, it's an ellipse, and negative, it's a hyperbola. So all those things are all on the bottom of this sheet. Okay, so we know this is a circle. If I want to know the information about this circle, like what is its center and radius, and sketch it, I would have to complete the square. So to complete the square, I group the x's together. So I'm going to have x squared minus 4x, and group the y's together. So, and I have y squared plus 6y. And I'm going to move the 3 to the other side. And then I complete the square on the x's and complete the square on the y's. So I told you a quick little shortcut on how to complete the square last class. Take the coefficient on the x, in this case it's -4, divide it in half and square it. So half of -4 is -2, square it and you get +4. Right, so I'm just adding +4 here. But if you add something to the left side of an equation, you have to also add it to the right. And then do the same thing on the y squared, or on the y's. I want to complete the square. Take half of the coefficient on y, which is 3, square it, and you get 9. But if you add 9 to the left, you got to add 9 to the right. Now, the whole purpose of doing that is that I have now created something that factors as a perfect square. That's why it's called completing the square. So this factors to x minus 2 squared. The y's now factor to y plus 3 squared. And 3 plus 4 is 7, plus 9 is 16. So where's the center of this circle? 2, -3. Remember, you always have to change the sign because the negative sign is built into the formula. And what's the radius of this circle? 4. So that's finding a conic section when it's in standard form. This one happens to be a circle. If you end up with these things with denominators, right? And this is 1, that would be an ellipse. If you end up with denominators and the right side 1 and a subtraction sign, that would be a hyperbola. Let's say x is 2 cosine t and y is 4 sine t. And I ask you, what kind of conic is this? And graph it. Well, you could graph it right away by making a little t, x, y chart. Right, you plug in different t's, you get the x's and the y's, and then you plot the x's and the y's. So for t's, I might just do like like 4 or 5 points. Something like that. And so if I plug a 0 into my x formula, what's the cosine of 0? 1. So 2 times 1 is 2. If you plug, oops, I don't know why I had to put negative there. Pi over 2. What's the cosine of pi over 2? 0. Times 2 is 0. And cosine of pi, Rich? Negative 1 times 2 is negative 2. Cosine of 3 pi over 2, 0 times 2 is 0. And the cosine of 2 pi is 1, so we get back to the 2 again. And then you do the same thing, plug into the y formula. The sine of 0 is 0. Sine of pi over 2 is 1. 4 times 1 is 4. The sine of pi is 0. The sine of 3 pi over 2 is negative 1. And sine of 2 pi is 0. And then I have a bunch of ordered pairs, x's and y's, so I could plot this thing without knowing anything about it, right? I'm just plotting points. So I've got 1, 2, 3, 4, 1, 2, 2, 0, 0, 4, negative 2, 0, 0, negative 4, and then I get back to 2, 0, and this is sort of hinting that this is an ellipse that has a vertical major axis. So we're thinking A is probably 4, and B, the half of the horizontal axis, would be 2. So just by looking at my picture, I might be able to say, oh, I think that this is an ellipse centered at 0, 0. So it would be x squared over a squared, which would be 4, and y squared over b squared. B, we're thinking, is 4. When you square it, you get 16 equals 1. So I'm just plugging the stuff I know about the ellipse into the general form of an ellipse. Right? So I think that that's going to be the equation, but let's eliminate the parameter just to be sure. So 2 cosine t and sine t. Okay, so whenever you're doing parametric that has trig functions that show up in it, use a Pythagorean identity to eliminate the parameter. So I know that cosine squared t plus sine squared t equals 1. So I want to solve for cosine t and solve for sine t and then substitute them into this other equation. Okay, so this is cosine t. If I were to just solve for the cosine t, I just divide both sides by 2. So I get x over 2. And this one, if I solve for sine t, I get y over 4. So then I plug those things into this Pythagorean identity. So I have x over 2 squared plus y over 4 squared equals 1. And then just simplify these, square these fractions. I get x squared over 4 plus y squared over 16 equals 1, which is exactly what I predicted I was going to get based off my sketch. All right, I like this one as an example because we're going to have to complete the square. So we'll do one more, get to do one more example where you see completing the square. And the coefficient on the x squared is 4 instead of 1. And when there's a coefficient on the squared term, the completing the square just has one extra little wrinkle. So I'll be able to show you that. And this one, not to spoil the surprise, turns out to be a hyperbola. So we'll graph a hyperbola, which we have not done together. Okay, so to complete the square, I'm going to group all the x's. So I have 4x squared plus 24x. And I'm going to group the y's. And I have a minus. And I'm going to put parentheses. Y squared minus 4y equals negative 36. So I pulled out a negative sign, so I'm doing some x squareds, some x stuff, minus some y stuff. So the negative on the y squared was the reason that I did that. And that means that I had to change the sign on the plus 4y so that if I distribute that negative, it's actually plus 4y. All right, on the x's, since there's a coefficient on x squared, I'm going to factor it out. So this is going to become 4 times x squared plus 6x. And then I have to add something in order to complete the square. And then y squared, I already have a coefficient of 1. And I got to add something to complete the square. And whatever I add on the left has to be added on the right. Okay, so you look at the x term, the 6x. The coefficient on x is 6. Divide it in half, you get 3, and square it, you get 9. So I've completed the square here. This x squared plus 6x plus 9, it's going to factor really nicely. Okay, and then the y stuff. Take the coefficient on y, it's -2, square it, and you get 4. Again, this is going to factor really nicely now. But whatever I add to the left, I have to add to the right. So over here on the left, when you distribute the 4 to get the 4x squared plus 24x that we had up here, we're going to actually have plus 36. Right? So we actually added 36 here, not just 9. So that's the little wrinkle when the coefficient is non-1. Okay. And over here, it looks like we added 4. Actually, let me do it. Minus y squared plus 4y. So it looks like we added 4, but really, because there's a negative sign out here, I really subtracted 4 from the left side. So that's really minus 4. So I have to add 36 and -4 to both sides. All right, so now this factors to 4 times x plus 3 squared minus y minus 2 squared. And then -36 plus 36, those cancel, and I'm just left with -4. And then in the standard form of any conic, except for a circle, but this isn't a circle, the right side is supposed to be 1. So to make the right side 1, I have to divide every term on both sides by that -4. Okay, so over here I end up with -x plus 3 squared over 1. And then here I have plus y minus 2 squared over 4. I'll put this over 1 equals 1. And then I'm just going to change the order of those so that it actually looks like a subtraction. Y minus 2 squared over 4 minus x plus 3 squared over 1 equals 1. All right. Would it be an up-down? Yes. The y term comes first, which makes it an opening up-down parabola. Yeah, hyperbola. Okay, so this is an up-down hyperbola. You know it's a hyperbola because subtraction rather than addition. If that was a plus, it would be an ellipse. So I know that its center is at 2, -3. And I know that, oh, you're absolutely right. Thank you. Yeah, the h coordinate always goes with the x. I did, I fell for it. -3, 2, yep. And then I can find my, I actually find it easier to just start graphing it at this point. So I'm going to put in the center. -3, 2. Okay, so it's a up-down hyperbola. My a value is 2, right? The a value is under the y there, or the a value always comes first, and it's 2. So that should be up to and down to from my center to make my vertical axis. So I go 1, 2, and down 2. There's my vertical axis. And then my horizontal axis is my B value, which is 1. So I go left 1 and right 1. And then I have those 4 dots. I actually make a box with them, where I box in my center. Box in the center of the hyperbola. And then you connect the corners of the boxes of the box to create your asymptotes. So there are my asymptotes. And I know that this is an up-down hyperbola. So the actual hyperbola it's on its transverse axis and it opens towards its asymptotes. Sorry, it's on its major vertical axis. So the green is the actual graph. The rest of it is all just guidelines to help you draw it.